Good morning. So first I'm going to be going over math challenge number 6 from yesterday and then going on to math challenge 7. Yesterday, a little later in the day, I posted a float and sink challenge that was pretty fun, and I'm hoping to do another science activity today, later on today. That's a really fun one if you want to go ahead and look at that. And I'm going to do some card games today too that you can do with a lot of your facts. So when we started math challenge number 6, yesterday we talked about those math facts. I'm going to be talking about those a little bit every day because, those are something that we need to continue to work on. And whether you're watching and you're, a second grader, a third grader, a fourth grader, a fifth grader, whichever grade you're in, it's definitely something that you could be working on. We showed some different methods yesterday. Using the flashcards is really once you understand the concept. So if you're a second or a third grader, then you might want to be working on arrays so that students are really getting a visual picture of what is a multiplication fact before they're just memorizing numbers. Okay, so yesterday's we had 327 times 3 gives us 981. My division problem, a few friends that sent me pictures of the work that they did, you're going to notice you have a different answer for this, and that's because I noticed that you did 6,972 when you did it on your paper. So your check may have come out correctly, but that's because you just actually did a slightly different problem. So the answer to this problem, though, is 2,157 remainder 1, and the check works on that. Finding common denominators and comparing, 5/9 was larger, 4/6 was larger, 5/7 was larger, and 3/4 was larger. Over on the side, I did other possible common denominators. I saw a couple people that used 36 as their common denominator. That does work because 12 and 9 both multiply to 36. And down here on the bottom, there was a lot of different choices that I saw. So I just used 12 because 8/12 already had 12 as a denominator, and 4 does multiply up to 12. So that worked as well. You could have also just done the 12 times 4 and gotten 48 as your common denominator. Also 24 would have worked. Also 36 would have worked. So any of those would work, and you still should have gotten the same sign on the line, regardless of which one of the common denominators you used, as long as you multiply the top and the bottom by the same number. All right, so math challenge number 7. Okay, first one we are working with is a word problem. Clara had 7,963 cookies. She gave 1,693 to Madison. Then she divided the remaining cookies between Tavon, Andrea, and Hunter. How many does each of them receive, and are there any left over? Okay, so again, I'll zoom in on those numbers so we make sure we're getting those numbers down correctly. This is a 2-step problem because first she's giving some of those cookies away before she divides them up between the other friends. Okay, adding fractions, sorry, this is a little bit messy. I wanted to add it up to a little bit different number than I did, and maybe I should have started over. So this one, I did a little example on it because I do know that number bonds is sometimes a tough thing if you need help from parents at home, because number bonds are not something that we used for math when we were growing up. So sometimes they look a little bit confusing or, nonsensical. But for adding fractions, I do really like the use of the number bonds. It's really quick and easy to change an improper fraction, which means that the numerator is bigger than the denominator, into a mixed number. So if I took 3/4, 3/4, and 5/4, I'm going to leave my denominator the same because the number of pieces doesn't change. So if these are pizzas and they're cut into 4 pieces, here's 3 different pizzas. Okay, this one I ate 3/4 of, this one I ate 3/4 of, this one I ate a whole pizza and another piece of the next pizza. So when I add up my numerators, 3 and 3 is 6, 6 and 5 is 11. So I end up with 11 out of 4. But if I want to order pizza, I'm not going to call and say, I want 11/4. So when I pull them out, I pull out a whole. 4 out of 4 is a whole. Another 4 out of 4, that's another whole. So if I look at the numerator, so far I'm at 8. 4 and 4 is 8. So how many more do I need to get to 11? 3. 4 and 4 is 8, 9, 10, 11. So I have 1 whole another whole, and 3/4. So I have 2 and 3/4. Okay, so you're only adding up the numerators. That's what you're adding up. Okay, so the 3 problems for you to try are 6/9, 4/9, and 5/9. As a mixed number, what am I going to get? 3/7, 6/7, and 4/7, and 4/5, 4/5, and 3/5. Okay, so you want to add up those numerators, then pull out the wholes and see what the total is as a mixed number. Okay, then on the bottom, we have some angles. What types of angles are these? Okay, so again, your choices will be acute, a right angle, obtuse, or a straight angle. Those are going to be your choices that you're going to write on the lines. And we have 93 degrees, 147 degrees, 90 degrees, 180, 12, and 91. What are those angles? What kind of angles is each of those angles? All right, looking forward to getting some of these answers sent to me. Thanks.